Hey, Edminda. I'm just doing a little bit of work to set up the SEM right now. I'm not panicked. Although I guess I appreciate the Douglas Adams reference. Hasn't been much of a break yet, but been very safe, of course. And tomorrow I'll probably not do any work. Hello, duck, 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 goose. I'm trying to make the most of my week. So today I worked on a master's student thesis comments. They're having their defense on Monday next week, and worked on one of my master's students' proposal defenses, which is going to occur on Wednesday of next week. And then I've got another student who's defending their master's thesis the following week, a student defending their dissertation the following week, another student defending their proposal the following week, and I think I have 2 more. Just like a crazy number of them, of course, because as the semester comes to a close, everybody is trying to get themselves ready for the next thing, whatever that is.
Daddy is cute. Daddy is
Hey,
strong.
Corkboard, thank you for the subscription.
Daddy will not stop.
Welcome in. How are you doing? I'm just sort of tweaking things at the moment. This is my scanning electron microscope lab, and thank you for being here. Today we're going to do probably a pretty laid-back research-based stream where I'm going to mostly focus on this genus that I'm sort of focused in on right now, looking at an internal view of, this is Rhoicosphenia. It's an interesting genus, similar in some ways to Gomphanema, which is to say that it is asymmetric in one of the 2 main directions of symmetry for diatoms. For most diatoms with a Rayphi, they're typically either symmetrical along the axis or across the axis. So if we take the apex of the diatom and the other apex of the diatom and draw a straight line down the middle, that is the apical axis. And for this diatom, you could fold it basically along this axis, and then if it were a snowflake, you could cut out half of it, right? and then you could unfold the piece of paper and make this diatom. But if you folded it the other way, if you folded it this way, across the axis, the ends wouldn't match up. This one's a little skinnier, this one's a little bit wider, and the actual shape of the valve is a little bit different, sort of like a bowling pin, right? Or a Coke bottle, if you like. It has a symmetry where it can only be folded basically along this axis, not across it. And the diatom that's right next to it right here, this little guy, could actually be folded in two directions. It's what we call bilaterally symmetrical. And it's a primary way that we help sort of figure out things with diatoms. So Rhoicosphenia is sort of an interesting diatom because it has a raphe on one valve that only comes out just a little ways right here. Raphe is this structure that's basically a little slit in the valve, in the skeleton of the diatom. And for Rhoicosphenia, on one of the valves, the raphe only comes in a little ways into the valve. And that is usually the valve that's flexed in a convex way. And then the other valve is usually concave. And so they're sort of curved along the pervalvar axis. And its raphe on this end also only comes a little way into the valve. But on the other valve, the one that's actually concave on the valve face, the raphe comes all the way to the middle. And they basically are almost to the middle, and they basically meet. So that's sort of a characteristic of Rhoicosphenia, and as a result, when you see them in girdle view, so girdle view is basically the side view, a typical gomphonema looks like this. There's sort of like a wedge in the pervalvar axis. In other words, one side of the diatom is narrower than the other side of the diatom. And this allows us to very easily identify that is a gomphonema, or something that belongs with the gomphonemoids, and that's a gomphonema. It belongs with something with the gomphonemoids. So it could be Gomphosinica or Gomphonese or Gomphonema or Gomphonella, but it's basically in that group that used to be sort of in the sensu lato gomphonema. And this one is Rhoicosphenia. And we can tell that because one of the valve faces is slightly curved and the other one is also slightly curved. And even though it has this structure where one end is narrower than the other, on Rhoicosphenia the valve faces are curved. So this is the concave face, this is the convex face. And this one has a short raphe. This one would have a raphe that goes all the way along the valve face. So here we're just seeing it in side view. And before, the diatom that we were looking at, if I zoom out previously, so gomphonema, you can see them very easily now, hopefully. This is that same diatom as this one. I think same species. This is an internal view. This is a side view. This is the valve face of the curved face right here that we're looking at. And you can see there's another Rhoicosphenia. Here curved, here curved, here curved. Those are all Rhoicosphenia. We can easily pick them out. And these are gomphonema, easily picked out, or gomphonemoids, because they're wedge shaped. So Rhoicosphenia, gomphonema, Rhoicosphenia, 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 gomphonema. So it's very easy from girdle view to tell what we're looking at. It's a little bit more challenging sometimes to get the right views, to characterize them if we're trying to figure out what species they are, for example. Because while we can see that it's clearly a Rhoicosphenia, we may not know what the species is if we're only seeing it in girdle view. So my challenge for today that I'm sort of working on here, or plan to work on, is I want to look at these Rhoicosphenia from all these different sites and sort of see if I can figure out what the species are. And this sample that we're looking at right here is from Gull Lake, which is a Laura's project, or my graduate student Laura's project. And I need to rotate this around a little bit so that it's basically going 45-degree angle. And that means I need to subtract maybe about 20 degrees from its current angle, which my trusty scanning electron microscope actually does very well. And because it's curved, I actually don't need to get it completely perfect, but I actually want to rotate it back just a little bit further. And that's mostly just to maximize the size of the diatom. It's about optimizing the image for getting as close as possible and still encapsulating the entire diatom, right? So I want to basically be able to, from a zoomed out position, see the entire diatom. And then I just need to play around with the focus a little bit. So right now, we're at beam intensity 10, and usually when I take a picture, I reduce the beam intensity to 7 so it doesn't look quite so blurry. But I also don't want to have to wait a super long time to take the image, so somewhere between 6 and 7 is usually a good place where I'm just trying to basically characterize something, but I don't want to necessarily get something that's like for a poster, right? Maybe it would turn into a poster if there's something interesting, or maybe I want to get a really nice image if we decide that it's a new species. But actually taking this picture on beam intensity 7 at speed 7 is probably more than high enough quality for any publication if we decide that it's something new. So, and then I slow the speed of the beam down and make sure everything stayed in focus. It looks like it's all clear, and I'm going to just make an adjustment to the brightness and contrast settings, and then I'll actually be able to interact with chat a little bit. Normally for diatoms, when we're imaging them, we need a view. Girdle view is nice, but it's mostly additional. For most diatoms, what you want is the valve face and internal views and external views of the valve face, and then a close-up typically of the valve ends, each apex basically. And because this diatom has two different valves that are sort of different from each other, and they may actually have different expressions that are important for looking at the species, I actually have to do valve faces on the inside and outsides of both valves. So for Rhoicosphenia, what we would need is a picture from each end, a picture of the whole thing, internal, external, internal, external. So that's 12 photos. And then in this case, I could also get probably a girdle view, foot pull, and head pull. So 15 photos would probably be enough to completely see every feature that we could feasibly see for this diatom. So here you can see this sort of typical structure for diatoms. Let me take this picture, start the picture, and then I'll just talk a little bit, and then I'll see what chat has to say. So it's just going to be the way that the stream will be structured, where I'm kind of interacting intermittently around collecting the images that we have. So in this picture, you can actually see that the diatoms are sort of structured with two valves. And oh, hey, Artsy Chickadee, hello. Sorry, I should try to pop in here and give Dell a little shout out. Thank you, Dell. And a shout out to Artsy Chickadee. She does sort of drawing streams and sometimes with science content. Recently, she's been doing a bunch of sort of mineral drawings and some sort of scientific field notes stuff, which is cool. You should check her out. And Pacific Plankton, hello. You were trying. So you can see from this image, there's a sort of traditional character for diatoms. They have two valves. One of them is slightly larger than the other one, and then they fit together, sort of like a hat box or petri dishes or pokeball or whatever you want. They have two pieces that basically slide, with one being slightly smaller than the other. And you can see that in girdle view very readily. So the diatoms are on their side, and one of them is just a little bit bigger than the other, as evidenced right here, right? You can see that this one's just slightly overlapping with that one, and this one fits inside of that one, just like a little box, a little wooden box if you'd like. And And so this would be the lid, and that would be the base, or what we call the epitheca and hypotheca. And then there's this sort of strip of silica that goes around the outside edge, which we refer to as girdle bands. So valve face, girdle band, valve face, or valve, girdle band, valve creates a whole frustule. That's one diatom. A single-celled organism has two parts, and they're divided but such that one fits inside the other. And then, of course, they have all these little holes, which are basically one of the primary characteristics of diatoms is that they have siliceous skeletons, but the skeletons have a whole bunch of these sort of little holes. And then they're usually rather stunningly intricate, as you can see. The diatom that we're looking at is currently being magnified by 10,000 times. So just to give you some sense of it, the entire field of view is about 30 microns, or if there's 1,000 microns in a millimeter, so a very small fraction of a millimeter in terms of its length of the picture. That's the width of the picture. So this diatom is probably a little bit closer to like 35 or 40 across its total length. Oh, she's always apologizing because I can sometimes beat her to some of the moderator tasks. So, all right. This is Rhoicosphenia. If you came in late, I'm looking at Rhoicosphenia. The name is incredibly long and weird, but that's the genus name for this organism. And I'm just going to put this in its own little folder because it's a separate project that we're potentially working on. And this one is from Gull Lake, California. And I'm trying to characterize the species that we observe. And I think all of the Rhoicosphenia that we see belong to the same species in Gull Lake. And then there's another diatom that's also Rhoicosphenia that we see in Mountain Lake. So I have some materials from Mountain Lake, which actually Pacific Plankton contributed to the collection here. And then I have some materials from a stream in Idaho that also has Rhoicosphenia in it. And I think the Mountain Lake and Gull Lake ones are relatively simple in that there's just one Rhoicosphenia in each of them. But I think the one from the Idaho site has 3 or maybe 4 different species that are present. And so that's part of what I'm doing, is just kind of exploring the Rhoicosphenia diversity. And I think it'd be useful to get at least one picture like this where we're just zoomed in on the foot pole. Rhoicosphenia attach in life, so this cell would be attached using some sort of a stalk-like structure that it secretes out these holes at the bottom of the diatom, or the foot pole of the diatom. So it would be sort of standing up on the stalk and hanging out in the water column, and so it secretes a sort of little mucilage-like stalk out of this, and uses that to attach, usually to some sort of a hard substrate or to an algae. Rhoicosphenia are pretty interesting because as a group they usually indicate flowing water conditions or moving water energy. And so from a paleoecological point of view, I usually use them to tell me that there was some higher energy in a lake system, either water flowing into the lake like a stream, or near shore environments where there's a lot of wave energy. That's sort of typical. So I'm usually hanging out in Jay Renzella's stream a little bit late at night. Sometimes I'm waiting around for Pacific Plankton stream to start. So
Hey,
as a
Maui,
moderator for her.
sorry.
So I do hang out there as well. Oh, look at this. You got a subscription from Corkboard. Very generous. Thank you, Corkboard. Now you get all of the cool emotes that are beyond just the follower ones. There's a whole nice collection of emotes, and I've taken advantage of to add I think they added 4 new ones for some streamers, as well as the follower emotes. So now you got a giant stack of them. I've been told people really like the emotes. Feel free to spam them, and you can see them in a larger format on the screen as a result. Very cool. Yeah, thank you, Cork. Very generous. Giving thanks. Yeah, Thanksgiving is this week. It's on Thursday in the US. And so I probably am just going to chill at home for Thursday. Oops, sorry, I keep forgetting that I shrunk down the size of this a little bit. Also, if you note, I'm sporting this very cool hat, which was knit for me by Pacific Plankton, and it's got tentacles on it, which I'm told protect my head from my mind from being eaten by mind flayers. So I have it on now just in case there's any mind flayers out there. Too bad, suckers. You can't have it. And I'm pretty sure there was a mind flayer yesterday that stopped me on the street and told me what a nice hat I had, because they were clearly distracted by it as they were thinking about eating my brains. So it's okay. It's a very awesome hat, and very soft and warm, and it's a little cold in my lab sometimes, so that's nice. And then I also sent Pacific Plankton a very nice little cutting board as a gift, and yesterday it was in Kansas. It's working its way to San Francisco. I didn't check to see where it is today yet. But one that I made on stream. So if you're interested in woodworking and want to check out some of my woodworking stream, I think I was mostly just sanding stuff and cutting stuff. I didn't do any of the gluing component on stream, but you could use your imagination. So I just sort of smeared some glue on some pieces of wood and stuffed them together and then clamped them. I think I put pictures of the clamping all over the place on my Discord. So if you're curious, that's a place you could go check it out. So now that we have the girdle view of this diatom, we actually have to do the hard part, which is find views that aren't girdle views, because these were collected from living organisms, so the cells are still together. And it's a little more challenging for me to find cells that are broken open when it was collected from living material, because I want to see an internal view of the diatom skeleton. And also we need to have external views where it's standing up basically on one of the valve faces or the other, and I actually need both views. So here's a view of the convex side of the diatom. As I mentioned, it has one sort of shorter raphe valve and the other one with like a longer raphe on it, and this is the convex valve, but this is the valve face. So this is what it looks like on the face before we were looking at it on the side, and the SEM allows us to sort of get three-dimensional understanding of diatoms. You can also get it a little bit by using some optical dissection in the light microscope. You can tell that it's curved, you can see some of the features, but the scanning electron microscopes allows us to magnify it much, much greater and see a lot more detail as a result. So I'm gonna rotate it a little, hopefully get it. Maybe I went a little too far, I'm not sure. It's close. Needs to go back just a bit. Oops. Yeah, maybe. Just trying to optimize. There's a lot of guesswork at what angle I need to get things at. So I've got one, maybe two, three of the views that I need. And here's another set of 3. So there's the head pole, there's the foot pole, and here's the whole valve face. So if I were going to describe the species, if I think it's new, or Laura's sort of under the impression that it may be new, because we tried to figure out what species it belonged to, or rather she did, and went sort of deep into the literature to try to find things that are similar to it, and was not very successful. We came up with one that kind of looked like it, but not perfectly. And so I told her that while she was happily away on vacation, hanging out with her boyfriend, that I would do all of the SEM work for this project and try to figure out if we could get nice, clean views of this Rhoicosphenia. And then later on, I'll make her do all the hard work of actually writing the paper, so it'll balance out. There's a nice, clean shot, nothing obstructing of the valve face. And then we'll zoom in, we'll do just the foot pull Rayfi and the head pull Rayfi close-ups. And then we'll have, well, basically 5 of our 15 shots, or 6 of our 15 shots that we sort of projected as possibly needing. And then you can see here there's a nice little Gomphanema sitting next to it with its wedge-shaped profile in girdle view. Here's the head pull Rayfi. Here's the foot pull Rayfi. Here's the actual apical pore field, which is distinct in Ricocenia. And then this is what's called the sternum, or the midline of the diatom, where you see there's no striae. Striae is just Latin, it means stripe. And these little lines create stripes on the light microscope, so that we just adopted this term. The little dots are called puncti or areoli, and they make up the striae, and those characteristics kind of define species for us. So all good. Everything looks good in terms of the image quality, so I can just go ahead and collect it. And as I mentioned, we're sort of doing a research-based stream, so a little bit more focused on just one organism in this case. So, hey Anna. This is not from Idaho. This one is from Gull Lake, but I'm going to work my way over to the Idaho ones, and then we'll look at some of those Rhoicosphenia. So Anna here is also a diatomist, and she sent me some Rhoicosphenia. So I have Rhoicosphenia from Idaho that came from Anna. I have Rhoicosphenia that came from Mountain Lake, that came from Pacific Plankton, and then these ones from Gull Lake, which were collected by Laura. And basically I'm just trying to look at all of them in the little window that I have today between now and, say, I don't know, 3:30 or something. And then I got to go put together an air hockey table because I'm a dad. And Christmas is coming, and that's what we got for Thanksgiving tomorrow, is from my father-in-law, is an air hockey table. Shh, don't tell my daughter. Hopefully she's not watching the stream. Okay. You're thinking you might want to add some diatoms to your field illustrations. Oh, great. If you want some material to use for subjects for drawing, let me know. I have a lot of SEM images, and I'm happy to share them. Or you can just join my Discord. A lot of times after the streams, I will post pictures of the diatoms. Sometimes I colorize them like the ones that are in the images below me. Or rather, I should say often, those are what I post into the Discord. Or you can follow my Instagram page, and I post the pictures there, but the ones in Discord are actually higher quality. Also, I usually post them to Twitter, but usually just a sort of a smaller selection go to Twitter, and a pretty small selection also go to Instagram. So like I might collect, I don't know, 40 photos and put one of them into Instagram or Twitter as colorized. So sort of artistic side. Hey, Studio here? Why is it I don't see Studio? Oh, I see. Studio Cornix was on here as a guest. She also has her Instagram, and she usually comes by and visits. So, I need a magic finger or hand of God to come in and hold stuff for me. Magic fingers would be great. I need them for putting together the the kalimba that I made for on a different woodworking stream for Hannah, because it's hard on the fingers. Okay, I'm gonna label this one as convex and valve face. And then we're going to zoom in on the foot pole first, and we'll just look at the foot pole with a little bit more focus. As I said, I just like to sort of characterize each major aspect of the diatom. A lot of it's pretty similar, which is why we focus on the valve ends. And in the internal views on the middle, because most of the things are basically the same on the diatom in the middle part on the outside, and then on the inside, the very middle is usually different, and then the end parts are usually interesting or different. So focus on the parts that basically are a little different from each other, and then characterize those with nice close-up images like these. Let's see. What else do we need for happiness? Well, I don't know. Rhoicosphenia make me pretty happy. They're kind of a fun diatom. They've got like a little bit of everything, and very each one very sort of strange and interesting in shape. So magic fingers are the size of about 30 microns. Well, might be a little bit big even for these. You just had your booster. I got my booster like 2 weeks ago, and Carlin got hers the week before that, and my daughter got her first shots right the same week I think Carlin got hers. So our whole family is inoculated and boosted. So, although Sylvia's got, I think, another week before she gets her second round. So, the pictures on Discord are awesome. Yeah, a lot of them are the ones that show up down here as well. Or unless you mean pictures of other things. I could use some air hockey table size. I mean, I think it would be nice if we could just make them variable sized. I feel like if it's actually like God fingers or magic fingers, we should be able to like change the size. Coming Monday, good. Nice to know. Yeah, the arm hurting thing for a day or so, right? It's the only troublesome part. An emoji for lurking. Well, I have a whole bunch of options. I don't have a lot of word diatom emotes. I just have the diatom ones, and I did put one with a heart, so there's this one, right? But I could put in a secret one for lurking. You know, there's a bunch of secret hidden phrases you can use in the channel that make emotes pop up, so I could put one for lurking in there. Those would be a little bit easier. Like if you just type, I don't know, was there one for water bear, I think? I don't know, maybe there is. Oh yeah, there is. Just like secret words release emojis in my channel. They're not a secret if I tell you what they are, but let's see, this is the foot pole. And we can very easily then zoom up and get a head pole. I think it says in your profile that you're an art teacher. Is that right, Chickadee? So what's with all the science? If that's the case, is it just for fun, something to do, or you have a science background as well? I'm not complaining, just curious. You can see the girdle band right here has a little break in it, visible from the outside. And this one has sort of a messed up little Rayfy. Must not use it for anything because it's at the head pole on the side that it really can't use it to attach to anything. But you can see there still is, it tried to have a Rayfy anyway. So it gave it its best effort. Just probably isn't planning on using it, so it doesn't really care that it didn't turn out very great. What is the lurkiest diatom in the world? Well, it would need to be one that's sort of present all over the place, just never very abundant, right? I'm sure there's a bunch that sort of fit into that. Just fascinated by science, yeah. Good. I'm also fascinated by science, but it turns out it's my full-time job. And I'm sort of fascinated by art as well. So that's my side gig, is I do this sort of colorizing art imagery stuff for funsies. Fistolifera. That's a good one. Just disappears when you go to look at it. What software do I use for coloring? Corkboard, I actually did a whole stream about, I don't know, a month ago, where I went through the whole process of how I colorize the diatoms using some combination of Photoshop and Lightroom and sometimes Procreate. It just depends on whether I'm on my iPad or I'm on my desktop. When I'm on the desktop, I usually will use Photoshop right now because it has a lot of really cool tools in it that the other ones don't, but you can't really use them in the iPad version. But sometimes I just want to like chill and watch TV and do a little bit of editing, in which case I usually will do it in Lightroom mostly. And then I will typically bounce it over to Procreate to make gradient maps and that sort of thing. So I can colorize it a little bit more interesting, and then I usually send it back to Lightroom to edit it some more, and then sometimes send it back to Procreate. So one cool thing is that you can just sort of share the image back and forth between those two tools. And there's a lot of like hemming and hawing and I don't like this one, or I kind of like this one, or it gets ugly as I go, so I just stop and start over. But the nice part is that you can get Adobe Lightroom for an iPad or whatever for basically free if you get the light version of it, and you can do basically almost everything that I do from the light version of it. And then you'd have to buy Procreate, but it's not very expensive. And then that's a lot cheaper as an option if you were going to compare that to a subscription for Photoshop. And I probably wouldn't pay the subscription for Photoshop, but I'm a full-time professor, so I get the university pays for my Photoshop, so I just use it. No, all of the colors that you're seeing in all of those images... Oh, here's Studio Cormix. We were just talking about you, Studio. There's no color because the images come out the way that you see them in the one that I'm collecting here on the screen. It's made by using electrons, not light, and so as a result, basically, electrons don't have, wavelengths in the range of visible light spectrum, and so they don't produce color. What we get is just how many electrons are hitting a sensor. So essentially, black and white images are a reflection of intensity of electrons reaching the secondary detector, secondary electrons getting the secondary detector. And so it's basically kind of like if you had a flashlight and you pointed it at a surface, a certain amount of the light gets reflected back towards your eye, and where there's more light getting reflected back, it looks brighter. and where there's less light, it looks darker. So electrons basically do the same thing. We're firing electrons down onto the specimen, and then the sensor's off to the side, so it sees things basically as electrons come to it, and more electrons hitting it at a particular point tell it that that's a bright spot, and then it scans as it moves across the image. So it's not downloading images. Sometimes people think that's what's going on, but it's in fact drawing the image or building the image as we go. So dark spots are areas where the beam is hitting and not much light is coming, or electrons are coming back to the sensor, appearing as bright spots or dark spots. So it just does that one pixel at a time and moves across the stage, one pixel at a time, providing information about what's going on at that point. And it does it super fast, but it produces, renders an image from that, basically. And it looks three-dimensional because it's mostly giving us topographic information back from the specimen. So it's not a photograph in any way. It's built or rendered as it goes, pixel by pixel. And then I take those images and colorize them. So all the colors that you're seeing are basically, they start off like this in black and white, and then I put the colors on them. So they're just from my imagination, or sometimes from just playing around with things until they look kind of cool to me. So sometimes I stream as art, basically, because I will take these and colorize them and make them into something artistic. So, my opinion, artistic, I guess. So this is the head pole. Sorry, I got lost talking. Just stuck on an image. We could probably move on. Right. So yeah, none of those things are real color. So if you're looking for real color, yeah, it's just all phony color, false color, what we call false color images, like satellite images or something else that's false color. So now the hard part, which is finding one that's an internal view. That is not a Rhoicosphenia. Finding one that's an internal view, and also not filled with junk, like that's filled with junk, right? Because it's got an open container, basically, and stuff will fall into it. This one might be. This is a Ricocenia, I think. It's got a very strong, what's called a pseudosepta up here at the top of the valve. But it's, the bottom part of it's covered. It's also very dark as a result. And I think this is actually the short Rayfy valve, because I don't see a Rayfy. And I'm thinking it's probably just up here in the top part. Just outside of our focal height, right there. Yeah, so there's the Rayfy. It's just a short little thing right there. And I think I might use this just to capture that head pull Rayfy. It's not a perfect image. But I think I can fix some of that. If I just fix the brightness and contrast a bit. It's thinking. Do we know what colors they are? Yeah, they don't have color in real life. The valves are made out of opaline silica, which is clear. So in real life, they're translucent. But the diatoms that are alive have chloroplasts and pigments in them, which make them sort of an orange or golden color, which is why they're often called golden brown algae or golden algae in the group that they belong to. So those pictures that Studio has on her Instagram are in some cases sort of rendered in the color with the pigments, because you can actually see the chloroplasts and stuff in them. So and then finding the other valve in both views, yeah, that's the challenge. Yeah, you can also see a lot of the living diatoms if you just check out Pacific Plankton stream. Sometimes I stream also live from a light microscope, less frequently recently because I've been trying to get work done. So, or I'm just trying to recover from having worked all day. So I tend to not focus on it very much at home like I used to. Let's see, I want this to actually be rotated around. I don't know. I'm going to go with 0 and see where that gets us. I did a pretty good guess. As usual. Okay. So I'm just squinting a little as I try to figure out what I want to focus on. I think I want this Rayfie in focus. This looks good enough to me for what we're aiming to get out of it. Okay, let's see. Are diatoms animals, vegetables, or minerals? None of those. Diatoms are stramentopiles. The easiest way to explain them to people who aren't scientists is say that they are algae. But algae is like a garbage group. It just means something that's microscopic usually, and single-celled. But then again, algae sometimes it doesn't mean either of those things either. Like kelp, for example, are usually considered an algae. But largely, most of the algae are single-celled aquatic organisms that have chloroplasts. Sometimes it also includes things like blue-green algae, or technically cyanobacteria, still a garbage group, right? So, but it's a lot easier to tell people that than to try to explain to them what a stramentopile is and why they're missing the 3 flagellate that the rest of the stramentopiles have, or any of that other nonsense. So, going to be going soon. Oh, it's fine. Easy mode. This is awesome. I like it. It's sort of my day job. So on top of that, it's kind of cool for me as well. Yeah, have a good Thanksgiving, Pacific. I'm sure I'll chat with you on Discord or something between now and then. Hopefully your mom's surgery goes well. So good luck. So algae isn't that legit of a categorization. Yeah, no, it's just a broad category. It's a little less simple than plants and animals. It's difficult because we have a bias towards the things that are larger, right? Like people know what a plant or an insect or a fish is, because we're used to seeing sort of large organisms, whereas diatoms are the size of dust. They're not visible, or if they're visible, they're only visible as like a sparkle or a glint in the water for the most part. So we tend to just sort of lump them into these very broad categories. And algae is just kind of a garbage dump, where we put things that have chloroplasts or function like plants but aren't plants, basically. So plant-like non-plants is basically what algae are, right? So it's like a garbage group. genetically probably are not reliable terms, but this is internal convex. It's not to say that you don't know what an algae is just from the word algae, but rather lots of things get called algae, right? It's just a very broad category. Okay, let's see what we can find elsewhere. Might help if I increase the beam intensity if I'm going to be looking around. At this height. Potential. So there's one, junk in the middle, so I can't see the internal middle of the valve, but I can see, this is again the convex valve. And it's definitely over brightened. And I need to rotate it a little bit. Maybe 15 degrees. It's got a piece of junk in it right here, so like I don't want that junk. But I think I'm going to be zoomed in closer than that junk anyway to see the end of the valve a little bit better. So I think this is okay for an image. Also, I think you can really see the Rayfy end in this one. The very end of it has like a little crochet hook kind of a shape to it. Just trying to maximize the visibility of it, and then I'm going to zoom out a little bit and we can image that. So I think it's in good shape, with the exception of maybe just being a little off center. There we go. So we got the foot pole, the head pole of the convex on the inside, the outside, and the whole valve on the outside. We need a whole valve internal view that doesn't have any junk on it from the convex side, and then we don't have any of the concave views so far. So there's a bunch of concave views I still need to collect. Organism, the right term? Yes, it is an organism. It's living. It's made out of carbon and silica. Sometimes seaweed is included in algae, sometimes, yeah, exactly. The more I try to understand and apply science, the more I realize humans need to categorize stuff inhibits my real understanding. Yeah, I hate labels, and I feel like we use labels sort of indiscriminately sometimes. That's just because I'm in the Gen X group, and Gen X group people hate labels, including the Gen X label. So, so hasn't gotten any easier for me either. Something that photosynthesizes and lives in water. As long as it doesn't have a vascular system, it's usually considered to be algae. So, all right, cool. Thanks for hanging out with us, Artsy. Glad to see you around, and hopefully I can catch one of your streams a little bit more. I sometimes tune in for just a little bit. I think you were drawing genes the last time I saw the stream, but a lot of times it seems like it's between my classes, so I can only sort of check in for a little bit. Are these images from an electron microscope? We're actually collecting the images. This is the electron microscope right here that is creating the images that you see below me that I've colorized. This image over here is, over here, trying to make it point with the wide angle lens makes my finger go all over the place. That one is being collected live, and this other one over here is actually looking into the SEM as we're using it. So we're on the microscope right now, and there's sort of a faint hum in the background. That's because the vacuum pump is running, and I've got my coat draped over it to try to keep the noise down. So if you hear the faint humming, it's not because the lights in the room are weird or anything. That's because we're in my scanning electron microscope lab. This is the lab right here. So I could show you. I sometimes will do a little like, here's what's going on. Provided I can get the Droid Cam to work. Sometimes it's a little flaky. The next time I get a break. So let's see, this is... Seems to work. Okay. We'll take another break next time after I move on to get the next picture, and then I'll do a little... This is the... foot pull. Let's see what we have up here. That's the same view, internal. This is the convex valve. And I need the other one. The view from the inside that has the Rayfans that meet in the middle. And it seems like this is also a convex view. However, that one's clean in the middle, so I'm going to rotate it. Let's see, something like 40 degrees to get the corner-to-corner action. I think maybe it needs to go a little farther. Maybe even a little farther. Oh, maybe this does actually have the Rayfans. Looks like the Rayfans comes all the way up. This is the concave valve. Because there's the Rayfans. Well, that's nice. That solves a lot of problems all at once. And then I can do like a quick little, here's with the SEM lab. I won't spend a whole lot of time going through it, but just for people who haven't been here before, I can show you around very quickly. So I was fixing the brightness and contrast, which seems like it's adjusted very well. Give me 1 second as it sort of rolls over this image so I can make sure that the focus is where I want it. I think it looks good. Okay. And then, let's see. Here you go. You can see that's the streaming software. Here's the scanning electron microscope itself. That's the EDAX component, which tells us elemental information. That's the secondary detector right there, which is collecting the image information for us pixel by pixel. That's the infrared camera that looks into the chamber. And then this is a drawer that opens up, and the samples basically go inside that chamber. There's some examples of SEM stubs. My finger for comparison. They're very small, and we're looking at just a tiny little piece of the surface of one of those. And then this runs on a computer. This is the TestScan Vega 3. That's the computer that runs the TestScan, and that one over there is the computer that runs the EDAX. And over here is the sputter coder. So samples get coated in gold. You can see they have sort of like a goldish cast to them. And so they go from the sputter coder into the scanning electron microscope, and then we can look at them. So it's a very quick tour of the lab. Just for clarity, use some tweezers and turn it around. I don't need to use tweezers to turn it around. I actually can rotate the image whenever I like, because I have a TestScan Vega 3 and I can just tell it what angle I want it to be in. So, junk in the valve, yeah, not in the trunk. You missed the hum of the lab, yeah. Well, I got a little bit quieter than usual, so think about going back to school and getting an MS in physics or engineering. Oh, cool. Yeah, I still need to get the other side, and I need to get like head pole, foot pole images here. Do you ever walk around in the world with an eye patch so you can practice seeing 2D in a 3D world? No. But probably my brain would still make things 3D because I'm used to seeing things 3D. So, why are the stubs not covered? Well, it's not a very dusty environment, and I'm kind of lazy about it. So, some of them are, some of them aren't. I need to buy a bunch of little bins, you know, to put stuff in, because I got all those samples back there that are also uncovered, but I just ran out of cabinet space for them, so I just run with them without any sort of covering like a crazy person. Most of the time I have images from everything from the stubs that I need, so they're just mostly there for archive purposes, and I still have the original material, so I could easily make more stubs for basically everything. So they're kept mostly out of convenience, so I don't have to remake them if I need to get some information again. So this is the internal concave valve. And we can do a close-up in here and close-up on either end. Those are the sort of tasks that I have. Nice part about them is once you kind of have them in focus and you have the angles set the way that you want, these images collect very quickly, because while I have to wait basically 3 minutes for it to render a diatom image, the hard part's actually finding the diatoms, not actually collecting the images. So if I weren't streaming and I was working on this scanning electron microscope, which trust me happens, I usually check my mail during this time frame or look through my messages and interact with whatever diatom Anna has sent me every day to try to figure out what little thing I can barely see in the light microscope could possibly be as a challenge. So that's what I would normally be doing. What's special about this Rhoicosphenia? Well, no, not every day. Many days. I'm not complaining. Once a week. Well, there was a period there where I think I got one every day for a while. Uh, what's special about it? So I think the thing that it maps out closest to, when you look at the size series and everything else associated with it, was Rhoicosphenia lacustris, which was described from Europe, and it doesn't seem to match anything else, and it doesn't perfectly match with respect to the outline of Rhoicosphenia lacustris. So I think what we're going to do is characterize it with our SEM images and then light microscope images, and then send it off to Zlatko and see if Zlatko thinks that it's lacustris. It doesn't feel like lacustris. Yeah, well, that's the way that Laura feels about it. She looked at it and thought, this doesn't feel like lacustris. Like there's something off about it. And I said, well, we have SEM. I have some pictures of it. We can get some more. So that's what we're doing. We're collecting some more. I figure we can hammer out the details of things like puncti distances and densities, and then and look at the details of the pseudosepta and girdle views and everything else. And then we'll do like a series of images from the light microscope as if we were going to make it into a new species, and then we would just ship it off to Zlatko and say, hey, is this a new species or not? But I figured while I was doing it, I should also look at the Rhoicosphenia from Mountain Lake, which I also thought didn't look like any of the known Rhoicosphenia that I knew, but I also don't know all of them. And then look at the one from Idaho. And then I thought maybe as a group, we could just put them all out. Here's some more Rhoicosphenia that people didn't know, or that we could add them to Diatoms of North America, in any case, if they are known species. So yeah, I think you think there's 4. I think there's at least 3, but I also haven't looked closely at them. You have. I was focused on other things in those samples, which nothing has happened with either, as far as I know. So I also need to put some pressure on Pat to see what he's been up to. Foot pull. And see if he can make any progress, or what we should do with the Gomphonis and Gomphonema from there. But I thought this would help to at least get something started with Rhoicosphenia, and then we can explore a little bit more whether it's a new species or what it is, and then potentially just stuff them all in one Rhoicosphenia paper, potentially, since how they're all from North America and the western part of the US in particular, and we have questions about all of them, or many of them. So I have them all on, actually in the SEM right now. All those stubs in there have Rhoicosphenia from all these different projects, which is kind of neat, that I can just put them all in at once, and then we could just look at one to the next to the next. But I think given how long it's taken to collect these ones, I might get to Mountain Lake, and then I won't even get through all the way through the Mountain Lake ones. But because Mountain Lake and Gull Lake aren't very far from each other, it's possible that they're the same Rhoicosphenia in them, so we could at least explore that. So on my questions for the day, and then Saturday, maybe I'll come back into the lab and try to get the rest of it. So does this SEM need a vacuum? All SEMs need a vacuum. 10x programmer, there's no way that you could run an electron beam through a chamber that's not evacuated, because it would run into air particles. Even the environmental mode, which this one has, which is a low vacuum mode, requires that you evacuate the chamber. There's no way to run a scanning electron microscope. Electrons have to pass through, so yes, it has to have a vacuum. And the diatoms are skeletal. These are their bones, basically. So they don't survive, but the materials don't get destroyed by a vacuum. It's a pretty strong vacuum pressure in there. I think it's like right now it's 3.5 times 10 to the minus 2 pascals. So it's a high pressure, or low pressure I should say, high vacuum mode that it's in currently. And yeah, there's not a lot of air left in there. And then, I mean, they're silica, so they don't compact under vacuum pressure, or actually the other way either. You can put them under a lot of high pressure stress, and they, unless it's forced on a point, they also won't break. So, how would you go about making an emoji from Fistalifera? I guess I would take one of the pictures from a TEM or something. I don't know. I think that there's pictures of them out there. They're just not very good ones. Person at the Smithsonian got back to me, and they need to go look at the records and samples in the collection in person because all of the records are written in old-timey cursive. Old-timey cursive is a good cursive, I feel. Probably the best cursive. I had a lot of flourishes back then. Okay, this is the head pole. We really just need an external view of the concave valve to reach the sort of everything on here that we needed kind of mode. Let's see, I want to move this to the middle for the moment. And then that is an interesting, they're usually kind of shaped like this sort of teardrop shape. So we need to kind of maximize the contrast in this thing. Let's figure out where that is somewhere around there. And then one of the things that kind of makes Rhoicosphenia interesting as a genus is that the Proximal Rayfans, the ones that are in the middle of the valve, don't actually they don't meet each other very closely. They actually, this is as close as they often get. So there's a big central nodule like area here that's sort of characteristic of the group and allows you to very quickly tell that you're looking at Rhoicosphenia versus something else like a Gumphonema. That plus the Pseudosepta. These look good. That's a good, should be a good internal view of the Rayfi structure. I can't even read old-timey cursive. I can't read what students write half the time even though they don't use cursive at all. Well, I mean, sometimes students have just a hard time expressing themselves, whether it's in typewritten form or handwritten form. And I suppose the more handwritten form it is, the harder it is for them to express themselves correctly. So I feel like my handwriting is degraded quite a bit because I don't write by hand very frequently. And so I find when I go to write stuff that, like, really my handwriting is degraded a lot. And then just even writing relatively small passages makes my hands hurt. So take some training. I've been reading old-timey cursive in Victorian German, which is next level. You do a lot of next level stuff, Studio. I feel like got a lot of challenge level in your in your daily engagements of some type. Got a lot challenging going on. This looks good. It's going to be a good, clean view of the internal. We got all the internal views and most of the external views, and now we just need to find a concave external valve view. We're one view away, and then we'll be done with characterizing this Rhoicosphenia, and we can move over to the mountain lake ones. Gotta love non-standard spelling of defunct place names. Sounds challenging. Well, at least you got some answer from the Smithsonian. I'm working on a project with them, with my colleagues in the Smithsonian from the Ricocinia Basin. There's a whole bunch of stuff on their website about it. And they've been giving me the runaround on a contract that they're supposed to pay me like $10,000 so that I can pay my grad student $10,000. Or actually, I think she's only going to get like $6,000 of it, but it's been going on since like June. I've been trying to get them to give me the money so that I can give it to her so that we can do the research. And we're still in a perpetual waiting for something to happen. And every couple of weeks I talk to my Office of Sponsored Programs and I remind them, aren't we supposed to have money from these guys? And she goes, oh yeah. And then she sends them an email, and then they say, oh, we should have this sorted out by tomorrow or the next day. And then 2 weeks later, I send another email to my Office of Sponsored Programs going, anything? That's a Gomphanese. Looks like. Not a Rhoicosphenia. Now comes the hard part. The elusive concave valve face view Rhoicosphenia. The only missing view. You would think with a whole valve, if I could get the other view, I should be able to get the valve view. Seems like it should happen. Is this Diatoma? That's a Diatoma. Especially if they disarticulate, you should be able to get that view, I feel like. Got one flat side and one curved side. I think it would land on the curved side. Or land on the flat side, I mean. At least occasionally. What's this big old thing? Navicula. There's gonna just be some searching here for a bit until I can find it, so it's your chance to say stuff in the channel, wait for me to come back to it. It's a good time to write something really insulting, I think. It's just gonna sit there until I get a moderator or I fix it. Oh, look. It's the head pull. Wrong side. We're getting close to the edge of the stub on this end. So I'm just going to go the other way a bit. Just kind of drifting around recklessly, hoping I find a diatom in the Ricocinia group that's face up, so I can zoom in on it. Oops. This one's face up. Yeah, that's it. There's the Rayfy. Just got a little bit of junk on one side, which I think I can just tolerate. Alright, I need to rotate it maybe 10 degrees. And looks like we did it. We got all the necessary views. Or we will have soon. There is the central, external, concave valve. And as long as I'm here and it's already in focus, I will just go ahead and take the picture. Let's see. I have mixed results with the Smithsonian people. Sometimes they are great, sometimes they kind of stonewall you. Well, I mean, these are people that I know. I don't think they're intentionally stonewalling me. I just think they tend to forget about what I'm doing. And then later on they asked me for results, and I'm like, you still haven't paid me, so I still haven't paid my students, so they still haven't done the work. And then they go, oh, you're right. So just a normal, academic situation where people forget about things they've committed to, I think. You're gonna cry about the Navicula? Well, I mean, I have an affiliation with an institution, and I mean, they came seeking me, so I feel like I'm kind of a big deal. Smithsonian came to me and asked me if I wanted to work on this project with them, not the other way around. Yeah, it does have sort of a little fake stigma, but I don't think that's what that is. Because the Rhoicosphenia don't have stigmata. It's got a dent. It doesn't go all the way through. It's like I thought about making another areole or something there. So we'll get this image, And then, let's see, I want to lock that. Something on here is unlocked. Oh, I see. There we go. Oh, hi, Lisa. What's the interesting feature we're looking at? Oh, this is a external view of the concave valve of Rhoicosphenia on the valve face. And this is the central area. So it's just where the raphe join together. And I'm working on characterizing this species, which I don't know what it is for sure, or if it may be a new one. This one is from Gull Lake, and I actually have a number of projects that recently I've been working on that have Ricocenia, which is this genus, which this species belongs in for certain.
Good news,
that,
everyone!
I don't know what species they are, and in some cases they may be new. They might be existing ones that I'm just not familiar with. There's a lot of, well, not a lot. Rhoicosphenia is a pretty small genus, but a lot of what has been described is in the primary literature and isn't in books yet. So there's not a lot of floral guides, or I think there's just a few of them on Diatoms of North America. I think maybe 3 are listed there. Which makes it challenging to identify them. So we have light microscoped images of these, and I'm working on basically collecting SEM images for this. If it's a new species, I now have all of the images that I need to actually describe it. And if it's an existing species, I now have all the features that I need in order to determine that. So what are the holes in it? The holes in it are called areolae or puncta, depending on who you talk to and how old they are, and how much they're used to using a scanning electron microscope. And the long line that runs through the valve is called a raphe. So these little holes are all called puncti, and that just means a hole. And this thing right here, this line, is called a raphe. And for diatoms, which is what this is their skeleton. They're a single-celled organism. This little hole, or this little slit that runs through the valve, is often how they reposition themselves. They can use it to crawl around, basically, kind of like a snail. And they move about as fast as a snail, but on a microscopic scale. And then on the other end are a bunch of other holes, which we'll look at, that are not these ones. So these areolae or puncti are lumped together into rows, which are called striae or stripes, and their shape and the orientation and all these other characteristics help us figure out what they are as species. So part of the reason I'm getting all these images is to figure out what species we're looking at with some certainty, and then to try to characterize it later. So we need to know like the density of puncti, and then the density of striae, and then we need to know like the way that they look on the ends of the valve, and then what happens with the raphe. So you can see that the raphe comes down to the end, it does a little bit of a wiggle, and then it ends right here in a tiny bit of a dilated opening, and then it's surrounded by basically a silica, unperforated silica hyaline area. And then you can see that the striae get very close to the raphe, so the axial area is very small for this particular Rhoicosphenia. And we were just looking at the proximal raphe ends. This is the distal raphe end that we're looking at now. The proximal raphe ends are where they come together, the branches of the raphe come together in the center of the valve. In this valve. In the other valve, they actually don't come very far into the actual diatom. So this is the head pole that we're looking at on the concave valve. And Rhoicosphenia has a concave and a convex valve, One of them's, we'll see from, I can zoom out and show you one in girdle view when we're done with these images. But I'm just going to collect one more image. That is this one, which is the foot pole. And the foot pole is distinguished from the head pole by the presence of what's called an apical pore field, which you will see in a second when I slow the beam down. So here's all the same features. There's this raphy that comes up into the valve. And then these are the striae filled with puncti, or made of puncti. And as we come down the raphy here towards the foot pole, or the apex, you can see that this bottom part right here, this little bit of a cone at the bottom from this striae down, has a totally different characteristic. They're not in rows. The holes are a little smaller, and they have sort of a weird orientation. They're not slits. They're sort of round openings. And then the raphy bisects this and ends right here. And this is what we call an apical pore field. For this diatom, it uses this to secrete mucilage and create a stalk, and it lives on a stalk. So the bottom part of the foot pole is the part that it uses to attach to a little tiny stalk, and then attach to some hard substrate from there. So we're just going to go ahead and collect this image, which shows us the foot pole for this diatom, and then I'll just do one overview shot of the whole valve for this diatom, for this valve. How old the holes? How old are the holes? Well, everything on this diatom is about. Well, it died in July when Laura collected it from the field for this one. So the whole organism that we're looking at, its skeleton, is only about 4 months, 5 months old. It probably didn't live much longer than a month before it was collected. Do you ever need characteristics from the living cells to identify describing species? It helps. Chloroplast shapes sometimes are very helpful for separating things into genus. And so there's a value to them depending on the shape of the chloroplasts. And sometimes characteristics of the chloroplasts or how the organism lives are important to us, like whether they live in a colony or whether they live in sometimes they live in these sort of tube colonies or sheath colonies, which can be helpful for species level identification. Most of the time, I'm looking at stuff that's been collected from fossil material, from sediments, and so we don't have access to that. But these were collected from algae, so I know what the sample was that they were living on, and then we're going to use those, or Laura's going to use these to help reconstruct the environment where the ancient diatoms or the older diatoms were living. So stuff from the sediments that lives on algae and is in the sort of margin of the lakes would produce something like this Rhoicosphenia. And so it's helpful for us to know how it lived. But a lot of times the living material is not something that I have access to, so I don't get to see it that way. And then I sometimes get material from Pacific plankton, for example, from live stuff, and we'll do a prep where we don't process it at all so that we can still get all of the life behaviors. And I've got some examples of diatoms where we didn't process it, and you can still see stalks and things like that in the light microscope, or you can sometimes see pieces of that material, sort of degraded quality versions of it that are in the scanning electron microscope. So the striae are so beautiful. Yeah, I think in many cases the diatoms are very striking, and the little holes and all the little features actually make them sort of stand out from most other algae. Not to say that other algae can't be striking, but diatoms have an advantage in that they've made this siliceous skeleton, so their images and their body basically gets preserved in the fossil record. And Some of the other algae sometimes are preserved. I sometimes see things like Pediastrum and Cenodesmus and occasionally Starastrum in lake sediments, things like that. But it's mostly just because they have some really resistant sort of lignin sort of material in the organism that keeps it from completely degrading. So we'll get one overview shot of this guy, and then we're good to go with this one. I hope you reach your dreams. You know a whole lot, and it's kind of satisfying. Kind of reminds me of a shoe. Well, I should know a lot about this. I've been studying diatoms for 22 years now, and I'm a professor, so this is my job. Parts of my job. I do paleoecological research and diatom taxonomy, and I explore diatom evolution through lake sediment records. So I'm a paleontologist, a paleoecologist, a taxonomist, a geologist, a ecologist, and a sedimentologist, and a paleoclimatologist. So I wear a lot of hats. Just have this one really nice hat on today, though. But a lot of what I do is very interdisciplinary. So you have to know a lot to utilize diatoms, and you kind of have to be pretty good at taxonomy to use diatoms, because there's so much diversity in them that if you're not good at the taxonomy, you can't get reliable results from the ecological information, and then you can't really apply it paleoecologically. So I should know the president in a cool movie. Do you know the way they present scientists in movies is really ridiculous? For example, most of the movie scientists that I see live in mansions, but diatomists don't make a lot of money, and most scientists don't make a lot of money, and most of the money that we get from grants goes towards supporting students and their research. So, we live relatively modest lifestyles with modest cars, and we don't live in mansions. And some of us know the president. I worked with a guy who was on the president's council when I was at the USGS. Back when Barack Obama was our president, he was on the council as a scientist, but not a lot of scientists actually interact with politicians, and certainly not with the president very frequently. That's got to be a pretty rare case. Also, I think scientists in movies are, they get the kind of, from my aspect, I have a beard and I'm a white dude, so people sort of perceive scientists as being bearded white dudes, so they got that part right for me. But a lot of scientists are women, and they're not really presented that way in movies very frequently. So in my lab, all of the scientists are women besides me. I'm the only person in my lab. I've got my wife, and then 3 graduate students that are female, that are women scientists, and then I have 4 undergraduates that are women scientists in my lab. So there's 8 of them, and to 1 of me, I'm outnumbered. This is the full valve. Good. And in our department, I think the numbers between men and women are basically even. We have basically an even number of men and women. All right. So I think I promised somebody, maybe it was Lisa, that we would look at some in-girdle views, so you could kind of see what I was talking about here. This is the concave side that we've been looking at, and this is the convex side. So this diatom's curved. Its valve face is curved, and the curved face, this is the side that it attaches to things with, and this side is unattached in most cases. And then when it creates a stalk, it creates it from here, which is the foot pole, the narrow side, when you're looking at it in girdle view. So we imaged one in girdle view when we started, and then we did internal and external views of the convex side, and we just finished with internal and external views of the concave side. So we basically have all of the images we need to characterize this particular species. And then I'm going to jump over to the mountain lake sample. It's almost 3 o'clock. And I think there's some Rhoicosphenia in this one as well. There's a lot of Cerarella, apparently, in this particular sample. Hopefully I have one that... Oh, that's a Terpsino in there, a little baby Terpsino. And some Cymbellas. And these giant Cerarellas are everywhere. There's an Epithemia, a Diplanice. But what I'm looking for is not these guys, but another Rhoicosphenia, which I'm pretty sure we saw in this sample. Is that another Terpsino? Yeah, that's a girdle view of a Terpsino. It's a really pretty diatom. And also these Cymbella mexicanas are also really pretty diatoms. In close-up, you see that their striae have these like ridiculous areolae that are like hieroglyphic patterns. This is the way their areolae look. I think it's sort of fascinating and complex. Look at that thing. This thing that we're looking at is its maximum size here when I zoom out so that you can see the whole thing. The field of view is 1/10 of a millimeter, basically, in length. That's how big that thing is. 1/10 of 1 millimeter. And when we zoom in, look at the complexity of the areolae structure on this thing. That's 2 microns right there that we're looking at. And look at how complicated this thing looks. Very, very cool. That's Cymbella mexicana. Some variety of it, probably. I don't know if it's the nominate variety or not. It's not what I'm looking for. That's a Cerarella. Some more Cerarella. At the moment, that's a Terpsino. As I mentioned, these things have really cool structure. The apical pore fields or ocelles are broken off on this one, but it's got really cool structure to the valve face. This thing's highly degraded. It looks pretty rough. And the ends are broken out, which is where the finest puncti are on the valve. These little tiny holes. And those parts are busted out, which is probably a sign it's been transported. It's big enough. That's a big enough diatom that probably can take a little bit of damage from being wrestled about. You can see they're all over in here. Here's one. It's mostly Cerarella. But I'm pretty sure there was a Rhoicosphenia in this sample that I was like, what's this? And I need to find it before we can image it. I don't think it's going to be as easy to capture it as the other one, so might have to just take what it gives us with respect to what we find for now, and I might need to make some more stubs. That's Epithemia. It's an interesting little Symboplura. Yeah. Maybe.
Well, pull up a chair. Nothing is impossible. Not if you
These
can
are some
imagine
really
it.
large diatoms that are present all over in this sample. And these were collected, I think, from benthic habitat around the margin of Mountain Lake in California. So these were collected by Pacific Plankton. There's another view of that Terpsino.
Good news, everyone.
Again, its end's busted off on both ends. And then this is Mexicana back here, and there's a Cerarella. There's huge Cerarellas that are everywhere. That's a sponge spicule. You can see the sample's a little bit clumsy. It's very dense in the middle.
Well, pull up a chair.
That's epithemia. Oh, it's an Olicosira. There's an opportunity to play around with my focus to get it perfect. I didn't really set up the stigmation when we started the stream. I didn't think we would be zoomed in too closely on things. There, that's pretty well stigmated. I feel like there's probably another. Like I could probably do a little bit better. This is granulata. I think. Olicosira granulata. Keep getting distracted by all these other little things in here. It's a Pseudostarosira parasitica. We are zoomed in like crazy high right now. Like 120,000 times. And I think to get that any more focused, I actually have to reduce my beam intensity. That's pretty crazy. Looks good though. Okay. Stigmation's in good shape now. Let's do this. Hello, OX Sharmaji. What's been going on since I've been zoomed out? Why am I not taking pictures? I'll come back to the Terpsino. Let's see. I gotta see what I missed. It looks like I got raided by Jeepotastic. Jeepotastic? Thank you for the raid. Sorry, when I'm focused on things in the SEM, it's hard for me to see what's going on out here. So, let's see. I'm going to just scroll back through this a little bit, see if I can catch up. Kind of like bees, it looks like parts are ripping apart. Well, nothing's ripping apart. Everything's basically in position. Trying to be comically obtuse. That's fine. Let's see. Where's my white coat and safety specs? They're in my actual other lab.
Good news, everyone.
We do have lab coats in there. I just don't need them for this lab. Yeah, all scientists are strangely beautiful. Sorry if this is what you got. It's not strangely beautiful. It's just me. Scream at each other a lot. Well, real life scientists can scream at each other, but it's pretty uncommon. Most of us aren't jerks. You don't see biologists too often in movies. Not very frequently. I work at Indiana State University. Skillar Martin. Santas and scientists are pretty much typecast, yeah. Let's see. What's the coolest thing I've found? I've found a lot of stuff. I'm a guy who looks at the world full of invisible things. So, for most people, no one ever sees the sorts of things that I look at. And never will if they don't catch my stream, I suppose. Or buy a microscope. I think that I look at samples from all over planet Earth. I'm fortunate in that I have colleagues that work with me from many places. And so I see diatoms from all over the place. And a lot of them are interesting. I don't have to go very far. I found stuff in my koi pond that I thought was pretty cool. So it's my backyard. It's hard to put my finger on one of them. I've described a lot of species and some genera even. And diatoms in general are just sort of fascinating to look at, so I don't feel like... I guess I don't have to play favorites. I have least favorite ones, if that helps. I have ones that I don't like. There's a lot of these Cerrella in here. It's like Ioensis or something. And then these other ones, the long skinny ones here. Linearis-like looking ones. I'd like to have one of these Terpsno that's not all broken up, but I'd really like to find the Rhoicosphenia first. I don't know why I thought that they were so common. Oh, it's Calanese. That's what that is. It's Calanese amphispana. I thought it was a... Yeah, I thought it was a Semetopleura, but that is definitely Calanese. You can tell from now that I've got the stigmation set so you can actually see the striae. A little bit of work required. We answered that question pretty quickly. There's a bunch of weird stuff in here. Jepo-tastic, how was your stream? And I don't know you, I don't think. What was your stream about? Can you tell us a little bit? And then I'm sort of curious. We're looking at diatoms. These ones are from Mountain Lake, which is a lake in California. And they were sent to me by my friend Pacific Plankton. And previously we were looking at some from Gull Lake, California. That is a planethidium, I think. I know how you feel about planethidium, Anna. But we're not going to focus on it. I'm looking for things. I'm trying to be productive in my last little bit here before I run out of time and have to go do adult things. Oh, what's this? It's a Diplonese. Oh, what a cute little Diplonese. It's one of the peanut-shaped ones, but it's not the peanut-shaped one that I have in these little Panduriform ones. I have one like this from White Sands, but I don't think it's the species. There's another one of those Calanese. Actually, I should get a nice picture of one of those Calanese too while I'm at it. It's one of my wife's favorite diatoms. Amphispana, I mean. Not just Calanese. I distinctly remember a Ricosphenia in this stuff that was kind of pointy and not knowing what it was, and yet I can't find any in the stub. Don't know what that is. Look at all that crazy, intricate alphabet pores. That's what I call those. They look like little hieroglyphics. What's this long skinny thing anyway? What is this? It's just girdle bands. sort of Melisira. Well, I haven't even found any Rhoicosphenia yet. It's going to make it very difficult for me to look at the Rhoicosphenia. Maybe I need to go back and look at these slides a little and see how common it was, or rather uncommon. It's probably hidden somewhere in here amongst all these monster-sized Cerorella. There's so many Terpsino, and all of them have the ends broken out. Just every one of them seems to be busted. And I really want one where the ocelli are there. Oh, look, a little tiny Stephanodiscus up there. Alright, let's rotate that around and I can image that while we're here. So I need like 145. Oh, not far enough. Right in on those tiny little alveolate striae, which are diagnostic of pinnularia and calanies and chemopinnularia.
Pull up a chair.
And then we'll slow the beam down so we can get a nice highly resolved image out. Do a little brightness and contrast, and then I can actually try to use this time to catch up with chat. I'm going to take a slightly longer photo than usual because it has a bunch of really tiny features that I need to see in high resolution, and which I think would show up nicely in high resolution. So I've basically shrunk the beam intensity down a little bit farther than normal, and I'm just waiting for it to make adjustments to the brightness and contrast. So this up here is just a little bit overexposed, so it's going to probably darken the top part of this image. I just want to make sure that it's going to look okay. Seems like it's going to be good. The valve ends are very bizarre. Yeah, I think it's going to look good. Alright, and we'll snap this and I can come back and see what chat has been saying. And I got a 10-minute photo, so it'll give us plenty of time. Okay. Let's see. Is there a move or a TV show that shows scientists in a way that approximates your reality? Movie or a TV show? Not really. I can't think of one that kind of fits the way that most scientists behave that I've seen recently. I'll have to think about that one, Quark. Challenged me to a sing-off. What? Exactly. I don't know about singing. I'm in Indiana. Sorry, Indiana State University, not Georgia or Tennessee. Neither of those things. And not New York. Hey, Corkboard, you gave Lisa a gift sub. Going crazy today with that stuff. Is that a spine going down the middle? It's called a Rayfie in Diatoms. Terpsno is written with umlauts, yes. Which means it's an OE sound. Terpsinoe. Like a star constellation, the Frustral. We sell Frustrals, amazing, yes. Sorry to raid and run, I'm about to crash. Okay, no problem, Jeppo. If someone's still here from his stream, they can tell us what it is you've been doing. Dr. WD40 raided with a party of 188. While I was being raided and trying to get stuff ready for the previous one, I got raided again. Hello, Dr. WD40. We're on the Scanning Electron Microscope today. Hope you had a good stream. I didn't even see that you were streaming. It must have happened while between when I left for work and when I was trying to get everything ready here. What's the genus name of the slightly bumpy Christmas tree-shaped one? Cerarella, I think is what you're talking about. We'll take a look at one of those in a second. Thank you, Sam, for handing out the shout-outs as well. And definitely you should check out Dr. WD40. He's one of the premier science streamers on Twitch with great content, of course. And thank you for bringing in your people, your peeps. Welcome in, Raiders. We're looking on a scanning electron microscope of collecting information live from my scanning electron microscope lab. And this thing over here is a view inside the scanning electron microscope's chamber of the stubs that we're looking at. I have a beard. And this view over here is a live view of what we're taking images of right now, which is California Amphisbaena, which is a diatom from a lake in California called Mountain Lake. And these pictures down here are ones that I've added color to through artistic means of Photoshop and Lightroom. Studio, thanks for hanging out, and have a happy Thanksgiving. We'll see you later probably. So I want to see the first pics from Mars under such resolution. That would be cool. It would be nice to have some high resolution image pictures from Mars. Quark, thank you for hanging out with us and for all those gift subs. And I will try to have a great weekend. I'll try my best. I probably will be back here on Saturday unless something comes up, because I have some more work to do on these samples. How do I get the colorized images? I make those using Photoshop. Flowers says, hey, I was at IU, School of Music. Oh, cool, Flowers. Bloomington's a really cool city, and if I could have gotten a job there, I would have taken it. It's a pretty cool university with a lot bigger than Indiana State. I think our maximum size is something around 12,000 people, and IU is like a 50,000 sort of size school. Do you ever have predators trying to get at your koi? Yes. In fact, Mayor of Space, Constable, hello. I don't have any koi in my koi pond anymore. I just have goldfish because some predators came and ate all the koi, which were the largest fish I had in there. And I haven't replaced them because I feel like they're expensive, and then things just come and eat them. And if they eat my goldfish will just make more goldfish, but my koi haven't really been breeding. So I was just like, well, they're just in there getting bigger. And the goldfish are now very large, but they still don't get eaten as much. So, yes, Nitsi are the ones I don't like. Are we that far back? Sorry. Hi, Constabebel. What diatom systematics what's it based on? Morphology alone, or can you sequence them? Yes to both. It's mostly based on the skeletal morphology, but people have progressively been sequencing them more and more, and so there's a fair amount of information about their DNA sequencing sphere, but many species don't have genetic information yet, and so we're just basically in the infancy of this, and I don't think it's very well understood even where we are. There's still a lot of problems with the way that we look at the DNA for these, because there's sort of the chloroplast DNA and mitochondrial DNA, and there's sort of combinations of things that you have to look at to get all the information that you need. Yes, this is basically a collaboration between Pacific Plankton and I. She sometimes sends me samples. What were you saying about productiveness? I don't know. It was a while ago. Yes, Malasara. Super late to the raid. Needed to get back away from the mosquitoes. Oh, you were doing an outside stream. Great. So many pretties, yes. We've got a lot of really cool stuff under the microscope today. I've been mostly focusing on Rhoicosphenia. Also, hello, Digital Dick Quinley. David Quinley. The way in real life science happens is probably not interesting enough for TV viewers. Yeah, in real life science is kind of tedious. And while this is kind of cool, I think watching a picture develop for 10 minutes might be fascinating to somebody on Twitch. It probably isn't movie quality information. So, oh, Astro Canuck's here. That's with the beard. I see. Hey, Astro Canuck. Well, we got a bunch of guests that came in all at once, and then Artsy Chickadee came back. Did we give a shout out to Astro Canuck and Constababble? I don't know if that happened. Here. Did I just put it as Babble? Look at that. You got your own command. WD-40's got his own command. That's how we roll around here. I don't know if I gave one to Astro Canuck. Oh, look, I did. This is how we roll around here. We just have people who come to visit and they get their own commands. Hang out enough and be a streamer, and you get a command in my channel. The bots, I program these bots with some intensity, you know. Chickadee, if you just hang around a little bit, I'll just add one for you, no worries. But if you haven't been following any of those people, you definitely should. And you should also follow Artsy Chickadee. She does some streams with science content occasionally. Mostly she does artsy stuff. She's a artist by day. I can do it the old-fashioned way, just give you shout-outs. Actually, this is easier for me to type in the commands when people aren't here, and then try to remember what I gave nicknames for people as. So, yeah, so sorry this took for a while, but it's a diatom that, it's my wife's favorite diatom, or one of them, so I found it. And this one's not in terrible shape, it's a little broken up, but I figured that, you know, while I'm here, I'll get a picture of it. It's not what I was aiming for, but it's what I got. Sometimes in the scanning electron microscope, that's just what you have to take. This is Mountain Lake, and this is Calanice. Amphisbaena is the species. And it's got lateral lines right here that run along the valve. It's probably got longitudinal canals or something. And then these very distinct Calanice and Pinularia type striae, which are like a chamber on the inside and then just sort of like a mesh over the surface on the outside that define them. I think these are the Christmas tree ones you're talking about. These ones that are shaped a little bit like a Christmas tree. Those are Cervarella. And they're actually really interesting, extremely interesting diatoms. They're all over the place in this sample. They're these ones. I think that's the ones you're talking about. They're all over, everywhere in here. I'm just looking for Rhoicosphenia though, and I haven't seen any. So I've seen a lot of everything else that I'm not looking for. These Epithemia, Terpsinoe, Melisira, Oligocira, a bunch of different types of Cerarella and Epithemia. Epithemia have really interesting, intricate pores as well. They're like little cloverleaf shaped things. So let's zoom in and take a look at one of those for you while we're here. This one's actually pretty dissolved. All the little clover leaves are ripped out. So a lake is probably slightly alkaline, and it's dissolved a lot of the finer diatoms. That's my guess. They get a little bit of dissolution on the outside of them. So what did you have in your stream besides mosquitoes, WD-40? If you're still around. I know sometimes you get to like the end of the stream and then you're like, okay, we'll go raid and then I can go take a break, stop talking. And especially if you're doing an outdoor stream, there's a lot of like repositioning yourself, taking gear off. You know, actually a lot of times when I watch your streams at WD-40, you've got all this like gear around you. I feel like it would be kind of make me claustrophobic after a while. It's a sacrifice you make to do those outdoor streams. Oh look, it's alphabet pores again. You can see they have these really intricate hieroglyphic-like pores all the way through. There's a diatom valve on the other side. And look into that one. Well, my hopes for actually looking at Rhoicosphenia from the sample have been dashed a little bit. Let's see what we can find, and then we'll just browse around a little bit more. Maybe we'll stop and get some pictures of these cool things that we've run across, like this Cerarella or Terpsinoe. Or this Cerarella here. It's already at the right angle. Let's see what we can do about getting it in focus. These ones are really dark because they are in a depression. It's sometimes hard to get them in focus as a result. There. Maybe if we just zoom in on one of these, we can try to get the surface texture a little bit. Tricks for the SEM. Make the box very small that it's redrawing, and then you can slow it down a little bit more. It's not helping. Oh, it is helping. There, got the striae in focus. Right as I was about to give up, suddenly all the little striae came into focus. Here you can see it's covered with a bunch of little tiny holes on the valve face. A classic diatom characteristic. This is a monster diatom, which is, you know, I guess a bit of a oxymoron. 150 microns or more across. Let's see, we could actually measure it if we needed to, but it's going to be whatever the hypotenuse is of a square that has 150 microns. Somebody out there wants to do math, they can just do the math. Looks pretty sharp. We'll roll with it. Okay. I need to follow all these peeps. Terpsino looks a little bit like a Christmas tree, I guess. I give credit to those doing outdoor streams, maintaining solid connections. Yeah, it's super hard. They're in depression. Oh, dad jokes. Too early for you to do the math, Constababble? Well, okay. And we don't want other people doing the math. Here, I'll do it for you. It's actually pretty easy. Let's see, SEM, measurement. Oh, that's not the right tool. I need... where is the measurement tools on here? Oh, measurement. Here we go. I need to do this, and then somewhere down here is the other end of it. 180 microns-ish. That's what we got. In the 180 micron range. People who don't want to do math in the morning or the afternoon. I remember. Sometimes our teachers can do math. We got a little bit of a terpsino in this picture too. Just off on the one side right here. Just caught a little piece of it. Again, the apical pore field on the thing is broken off. The ocelli. This is nice and sharp though. It looks a little bit like the one that we use in the chat as the emote one. It looks a little bit like this guy. This Cerebrella, the blue one. But this one's distinctly heterovalve or heteropolar. So the ends are not the same, you know, they're not the same on both sides, what we call isopolar. This is heteropolar. Means one pole or one apex is basically a different shape than the other. So teardrop shaped or leaf shaped, or if you like Christmas tree shaped. I'm assuming this is the one that you meant earlier. I think that was Lisa. It's a Cerurella. Cerurella is a fun name to say, but a hard one to spell for most people. This is a benthic diatom. Lives on the bottom. Samples were collected from rock scrapings, I think. Here's another Cerurella, terpsino, Cimbella mexicana. Here's a terpsino that's upside down. We're seeing the inside view of that one. I want to actually see the other side of it. These Christmas tree looking ones, as we were calling them, the Cerurella, they actually have this Rayfy. You can't see it very well normally. The little slits that are usually running down the middle of the valve, on this one they run around on the outside edge like a little skate blade. This thing is called a keel, or on Cerurella, like this one, it's called an alar wing. And the Rayfy is up on a keel. These little pieces right here are called fibula. that are struts that basically hold up the Rayfi. Rayfi runs around the circumference completely. So one wing of the Rayfi runs this way, or one branch, and the other branch runs around the outside this way. Normally they run through the middle of the diatom, so you have to think of these diatoms as having basically shifted in space, so that the middle of the diatom is, I think, up here, and the valve ends are down here. So this is like the distal Rayfi ends, and these are the proximal Rayfi ends, which is very strange for most diatoms to have that sort of a shape. Non-traditional. Alright, let's zoom in and look at this. Again, the ends are broken off and it's covered with a little bit of junk, but that's terpsino. That's a dissolved pinularia laying next to it. If you're fascinated by diatoms and you're thinking about going to grad school, and you think, oh, maybe I could learn diatoms for grad school, where would I do such a thing? Our graduate school is actually accepting applications from now until January 15. You could work with me. You could run the SEM. It's a possibility. A plausible one for grad school. I have unfettered access to the scanning electron microscope. It's in my lab. And my students can use it on all of their projects if they like. Which is sort of an exception. When I went to grad school, I went to a very high-end school, Nebraska, it's an R1 university. I couldn't get access to the scanning electron microscope without giving them a couple weeks notice and scheduling it, and certainly couldn't just throw my samples on there and walk away the next day, or just tell them I need to use it. It's a pretty nice advantage to be able to have a lab like this. You can see this is a giant pinularia. It has similar structure to the one that we saw in the California species. Striae are just bigger. This is, again, monster-sized diatom, 160, 170 microns across. And I think this is Pinulari giga. Giga is its name, which is funny, because it's gigantic, right? Let's see. I want to go like minus 30 degrees, no, plus 30 degrees. Something like 150. Ooh, I do such a good job at guessing that sometimes. A little bit over. Let's go back to 145. And we'll just get an image of this gigas. Pinularia giga. While that's going on, I can entertain chat with some witty repartee. Possibly.
Good news, everyone!
Yeah, this could be you. You could be sitting right here running the SEM while I sit next to you and check my email. It could happen. You could be looking at these samples from Mountain Lake. And maybe we need to take a core from Mountain Lake. It seems like a place we could get access to. Looking good? I bet you need an undergrad in a scientific field. This is false. You need an undergrad degree to get to grad school, but you do not need to have it in a scientific field to work with me. One of my closest colleagues, Tricia Spanbauer, is a scientist who started off with a fine arts degree. Came into our program when I was a PhD student at Nebraska, and is now like one of those really like fancy diatom genetics studying people that I need to work with occasionally because I don't know how to do what she does. So, no, you don't need to have a scientific field. I think it helps, but it's not required. You have a bachelor's and a master's, but still don't think you have the necessary prerequisites. You're fine. You would just need to basically apply. There's some things that probably it's helpful to have a scientific background around, knowing how to do research, knowing how to write research, but those things can be trained. You can learn to do those things. You can learn to identify diatoms. Most of the people who come into my lab don't have any diatom background when they start. So training people to learn diatoms is part of the job that I do. And I teach a class on it. I have, interact with people quite a bit about it. Potentially we could send you off to a different school if you wanted to for this summer, to take classes at the Iowa Lakeside Labs Diatom Taxonomy course. But, don't necessarily, and I would say that of all the students that I've had come in at the grad student level, I don't think I've ever had one that came in trained as a diatomist. I have one right now, Laura, who learned from herself, who taught herself how to do diatoms when she was an undergrad, and then had some assistance, but never had any formal training. So, Constable, we'll see you later. Thank you for coming in and hanging out. Well, if you're thinking about doing scientific illustration, it's a good idea to have some background in science, but it's not necessary. I think you can do those parts with just the art skills. I have a friend who, when I worked at the USGS, she had an art degree and she was working there in the science facility as a graduate student, and I think she was doing science illustration for her master's degree, and then she was working in the science facility doing actual science. But I don't remember if she was a volunteer there or whether she actually had like a paid position. I think maybe she had a paid position there as an intern. But she was basically learning the scientific illustration stuff for her master's degree, and then she was doing actual science in the labs. So actually, one of the hardest things about diatoms, one of the hardest things about diatoms is shape recognition and being able to distinguish one group of diatoms from another group of diatoms based on their shape. So having art skills is actually kind of a valuable skill set. And one of the things about art illustration is that it requires observation, which is, again, critical skill, like being able to notice little details about things. And when I was learning diatoms, what we learned to do is basically draw them to identify them. And that's because you need to basically see the details in order to draw something. So there's a lot of overlap. So if it's something that you're interested in, not necessarily working with me, I'm not trying to sell you a used car here, but if it's something that you're really interested in doing, I feel like science illustration is kind of a cool and useful skill for scientists. All right. Well, I don't see myself finding Ricocinia in this pile of diatoms anytime soon, and it's already past when I wanted to stop streaming because I have to go put together an air hockey table, as I mentioned.
Well, pull up a chair.
As a dad duty. So, and then I think we're going to have our Christmas party next week, or end of the semester party, or whatever you want to call it, for my lab, which means probably tonight I'll be starting to clean our house up, so that by next week it's in reasonably good shape. But I think on Saturday I will be able to stream again, and I'll probably start poking around in the Idaho samples from this set, looking at the Rhoicosphenia in them. And I might come back and look at the light microscope samples from this material and see if I can figure out where the Rhoicosphenia that I saw are, because I'm pretty sure there were some in here. Okay. So that Anna isn't forever mad at me for not taking a picture of Terpsinoe. I will do that as my last act for today. This one looks like it's clean. Still has the ends broken. Still can't get the apical pore fields on it, but at least it's in good shape otherwise. It's not covered with junk. This is, again, another giant diatom. I don't know what species, but it's probably Terpsinoe musica, because that's the one that's usually observed from places in North America. And all of them look like they're pretty beaten up. So I feel like maybe they were collected from high wave energy environments. Let's see, let's put it on 8 for the speed. We'll do correction for brightness and contrast settings and snap a picture, and then start figuring out how to close down the stream here. So there was a lot of events today for a relatively small stream, where I'm just basically doing research. Sometimes we look at all kinds of things on the SEM in here, and this stream I just wanted to focus on trying to get some of my actual research done, so mission partly accomplished on that front. We did look at some Ricosphenia. I feel like we got the one from Gull Lake figured out. At least all of the parts are there. And then I didn't find anything that I wanted from Mountain Lake, but we found some cool things here. We saw some cool things. So there's that. Let's see. I will darken that just a bit and increase the resolution on the image, and then start that image collecting. It's going to take like 9 minutes to get to the end of it, so okay. Yeah, drawing what you see instead of what you think you see is tough, and it's true. It looks like it should be leopard print colored. I'll see if I can figure it out. All right, thanks everybody for hanging out. I'll probably post some of these things as images in the Discord. So, hello Shadowfax also. For people who haven't seen it, that's the Discord. Feel free to join it. It's no big pressure to do that. It's a relatively quiet place where I just kind of post images for art and things. Friends from the stream hang out. Sometimes I do a little bit of gaming streaming into the Discord channel. Some of my gaming activity, which I usually don't put on Twitch, but I do feel comfortable doing it, like, my Discord, if you want to just come hang out. Right now I've been working on Hollow Knight. I'm almost all the way through. I'm at the very end of it. It's a good game. Very challenging. Let's see. We got follows today from Danger Tater, from Rake Snake, LOL, from Maverick Wolf, from Mad Blood YT, from M Dillon, from Ryan BTB, from Barnacle Bum, some Sve2, Voldemort TTV, that looks like maybe they're a streamer. WD40 came in with a giant raid of 188 people. still some of those people are here, even though I'm not outside and not detecting metal or whatever it is that he does. Corkboard gave out a gift sub to Lisa Printmaking. We got rated by Jepotastic or Jepotastic, follows by Scalar Martin 22, a bit from Anonymous Cheer. Corkboard just going crazy also gave out a gift sub to Artsy Chickadee and then resubscribed themselves for the second month. Follows from Artsy Chickadee from a little bit earlier before the stream started. Thanks for hanging out, Duck Goose. That's basically all of the fancy events that have happened here in the stream. At this point, seeing as how we're reaching the end, I will find us somebody to go attack. We have choices. Music or music, basically, are my choices for the moment. Or we could go after... Also, there's one art streamer. I can be Danny, who I could potentially go see what they're up to. Let's see what we have. I'll try to see what people are doing before we go run and attack them. I don't know, he seems to be watching a TV show. Okay, let's go get Numb the Geek, one of my favorite streamers on Twitch.
Hey, Maui Sour.
Oh, look at this. Mr. Hamill showed up and gave a gift sub to WD40. Thank you for that, Mr. Hamill. You're very generous with the gift subs. You and Corkboard and Samshung. Got a bunch of really great people who sort of keep us afloat with subscriptions. I should also point out all the money that comes in as subscriptions goes to scientific research for my graduate and undergraduate students. And we'll be taking a big chunk of it from the recent subscriptions, and I'm going to use it to buy dating for Laura's cores. So we'll be able to put some age models on her core. So believe it or not, you're contributing directly to scientific research that will help her get stuff published with your subscriptions. So kind of cool to be able to get engaged in science like that. All right, let's go raid. We'll attack Numb the Geek. Numb the Geek. They're an incredible musician, super generous. Just basically will play anything you ask them to within reason. Great with the fiddle, guitar, and he plays banjo, mandolin. Sometimes you can get him to play little weird instruments as well. He's a super nice guy, and I haven't raided him in a while. Probably been about a month or something since we raided him, but he's probably the person I raid most frequently on my Wednesday streams, because he always is starts his streams basically around when I do on Wednesday, and then ends them sometime a few hours from now. So he's usually around. Okay, well, I hope everybody has a great Thanksgiving for the North American viewers, and for people coming from outside of the world. I also hopefully you guys have a good weekend. I'll probably be back on Saturday, but if not, probably next Wednesday. I've got a whole bunch of student thesis defenses and dissertation defenses and whatnot to deal with next week, but otherwise I should have most of my days kind of open. We'll see about Wednesday. All right, check us out. Check out the Instagram if you're interested in that sort of thing. And otherwise, we'll catch you next time. Enjoy.